next, we want to go into the calibration of instruments and instrumentation systems. So we know for us to improve the reliability of our instrumentation system, we need to be sure that the instrument is giving us what it is supposed to give us, the right reading at the right time. And that we can be sure of when we carry out calibration. So we want to look at instrument calibration, okay, to improve the reliability of the instrumentation system. So when we say calibration, what do we really mean? Okay, so when we say calibration, what we do is that we subject the instrument, okay, and another instrument of known behavior, of trusted behavior, of trusted responses, okay, to that process variable that we are actually measuring with that instrument. And then we'll compare the readings of both of them. Are we getting it? So if the reading of the meter is the same with that of the trusted meter or the trusted instrument, okay, that means the meter is very reliable, it's okay. So we can leave it and continue to use it. But if it is not, we make the necessary adjustment, okay, to bring it back to what is correct. Are we getting it? We make the adjustment to bring it back to it for it to give the same reading as the trusted instrument. We call that the master instrument, okay. Then if the instrument is one that we cannot really recalibrate, that is adjust again, okay, to suit the reading of the master instrument, then we need to replace that particular depending on the degree of deviation. Are we getting it? So if the deviation from what is normal is tolerable, which will be stated in the data sheet of the instrument. If it is tolerable, fine. If it is not, then we need to replace, okay? So basically in calibration, what we do is the comparison, okay, of the instrument reading with that of a reference instrument or a master instrument. Are we getting it? And then make the needed adjustments, okay? So what I'm trying to say is this: assume that this is the instrument that we want to calibrate, and this is our master instrument, okay? We'll subject them to the same condition. So this pressure meter, what we do is that we subject both of them to the same pressure, as you can see. So the master meter is giving us 464 kilopascal. Are we getting it? Then the one that we are looking at is giving us, that is the instrument that we want to calibrate, is giving us 463.09 kilopascal. So we have a little difference, that is about 1 or less than 1, okay? Less than 1 or about 1, okay? So if it is within the tolerable limit for this particular meter and for our own process, if 1 kilopascal difference will not affect our process, then we can continue using the meter. But if it will, we then adjust this meter, okay, to be sure that it gives us exactly this reading at these applied pressures. Are we getting it? Then if we cannot, then we replace this particular meter. Are we getting it? So that is the calibration we are talking about. So this is another example. Okay, this is another example. See 549, this is the master meter, subject them to the same pressure. We have 549 here, which is almost 550. Then here on the gauge, we have 550. So it is tolerable, we can use this meter. Okay, but if the difference is much and you cannot make that adjustment so that the meter, the reading of this meters we'll see later will be the same with that of the master meter, then we need to change the meter all together. Okay, so the next question is, why do we calibrate? The reasons are obvious. We calibrate so that the meter that we are using in our process will give us the accurate reading of those process variable in the process. Okay, and we know that as in our earlier discussion, that those process variables, as they are changing, the they can affect the outcome or the output of the process. They can affect our process, so we need to control those variables. So if our meters are out of calibration, it means that we'll be having false reading or reading that are not correct, and it means that our control will not be effective. Okay, so we need to be calibrating so as to know, to be sure that our meter is giving us the accurate reading at all times, so that we'll be able to control our process generally. So the next question is, how often should we calibrate? So the frequency of calibration is determined by a few factors. Okay, the condition to which the instrument is exposed. If it is harsh, it means that the frequency will increase. Are we getting it? And of course, the frequency of use of that particular instrument, okay, also determines the frequency of calibration. So some instruments, they are calibrated monthly, some are calibrated annually, some biannually, and some take some time, some years before they are calibrated. So it depends on the process condition that is subjected to, and the usage of that instrument. Okay, all of this determines the frequency of calibration. Okay, and there are also standards. Okay, industrial standards and regulatory requirements, can also determine the frequency of calibration of